Beginning with section 9.1. Today we're going to look at sequences. Chapter 9 is an interesting chapter. It has about 4 topics to it. The topics are sequences, L'Hopital's rule, which is a little bit of a repeat from AB, relative rates of growth, and improper integrals. So kind of a mixed bag of topics getting us ready for the chapter 10, where we will use those rates of growth idea, we'll use sequences idea. So it is kind of a prep. Oh, and improper. So it's just kind of setting up essential skills for the next chapter. We're going to break section 9.1 down into 2 days. So today we're going to look at defining a sequence like geometric and arithmetic. Oh, there they are, and arithmetic and geometric. So, and then tomorrow we'll work with graphing a sequence and the limits of sequences. So let me move that. And let's look at what we've got coming our way. Find the value of the limit. So just a little review idea here. If I'm headed to infinity, I want to look at what the end behavior of my graph is. And sometimes they end up being a horizontal asymptote. So if I can analyze the highest degree on top and bottom and determine that they're the same, then it's the ratio of the coefficients. So I know that this one is going to come out to be 2 over 4, or the limit would be 1/2. Its horizontal asymptote to the right is 1/2. Now, you're like, well, I don't remember those rules. Well, then the other thing you can do is you can take the highest degree in the bottom, which is x squared, and I can divide every single term by x squared. And simplify that out. So x squared over x squared cancels, gives me a 4. X over x squared, well, the bottom's going to grow faster, so that's going to take it to 0. 1 over x squared, that's going to go to 0, and I get 4 plus 0 plus 0 gives me 4. On the top, I get x squared over x squared, so I get a 2. And minus 2 divided by something super large, of course, is going to take us to 0. So I get 2 plus 0, and there is that same answer. The next one, the limit as x goes to 0. Well, if I put in 0, I'm going to have sine 4 times 0, or 0. Sine of 0 is 0. I get 0 over 0, which AP does not like us to write equals, because 0 over 0 is not defined. So I could say it goes towards 0 over 0. And that tells me that there is an answer. I just need to figure out how to get to the answer. And I remember that there is a theorem that as x goes to 0 of sine of something, I'll call it a heart, over a heart, that this is equal to 1. So same over same gets me 1. What I would love to do is have a 4x then on the bottom, but I can't just introduce 1/4 to my equation. I'd have to multiply by 4 over 4. And then I could sweep this 4 multiplier out front and have the limit as x goes to 0 of sine 4x over 4x equals 4 times 1, which is 4, because this entire limit would be going to 1. So there's just quick review. Defining a sequence. A sequence is simply a listing of things generated by a rule. More formally, a sequence is a function whose domain is the set of natural numbers. Natural numbers are the ones that you learn to count naturally, so like 1, 2, 3, 4, 5, such that the range of the function are called the terms in the sequence. So we can have some explicit rule. Maybe it's like 2 times n plus 1 could be our rule. And I would put in whatever term of the sequence that I'm on. If I'm on the first term, then n would be 1. If I'm on the second term of the sequence, n is 2, and so forth. So you can see that listing out there. If the domain is finite, then the sequence is called a finite sequence. If the domain is infinite, then the sequence is called an infinite sequence, meaning it doesn't end. A sub n is called the nth term of the sequences. Sequences can be expressed by listing out an ample number of terms so that a person could pick up what the pattern is. We separate those terms by commas. So if I had the sequence 2, 4, 6, 8, ... I think you'd be able to continue my sequence. We could describe it as an explicit function defined by the rule of the sequence. So for this one, maybe I'd write that the rule of my sequence is 2 times n. And that would be an explicit function. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. Oh, and the rule of the set off by brackets. So, or braces. Oh no, explicit function. Oh, a sub n equals 2 times n. I could write it like that. That's what number 2 is talking about. A sequence is a function f whose domain is the set of positive integers. So sequence notation, we can express the explicit rule in the braces. We can do listing out. We can graph out our sequences. So 1 is representing the number of the sequence or the term, and then a sub 1 would represent that outcome. So down below, example 1 lists the first 4 terms and the 10th term of each sequence. So we see our rule of sequence 5 plus 10 raised to the n power. So my a sub 10 or a sub n term would be 5 plus 10 raised to the n. My first term would be when n is 1. I put 1 in, I get 5 plus 10 is 15. When n is 2, I put in 2, that's 100 plus 5, looks like 105. Third term, n would be 3. That'd give me 1,000 plus 5, so 1,005. A sub 4 would be, n would be equal to 4. I am going to have 1,000, or I'm sorry, 10,005. And I just go ... They want us to get to the 10th term. Okay, so I'm going to have 10 zeros. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it will be the 5. Put some commas in the place. Perfect. List the first 4 terms and the 10th term. For the next one, negative 1 raised to the n plus 1. This will end up shifting between negative, positive, or perhaps positive, negative. I do know it's an alternating positive, negative, positive scenario. I'm just going to have to decide, am I starting negative or am I starting positive? And then I've got n squared over 3n minus 1. So my rule of sequence would be a sub n equals negative 1 to the n plus 1, n squared over 3n minus 1. And then let's let n equal 1. Put 1 in. Looks like I get an even number. 1 plus 1 is 2, so negative 1 squared would be positive. So I'm going to start out with positive. I'm going to have a 1 over 3 minus 1, 1/2. My next term of the sequence, put in 2. So 2 plus 1 is 3. This is going to be negative. 2 squared is 4 for numerator. And 2 times 3 is 6. 6 minus 1 is 5, comma. Let n equal 3. So throw 3 in. 3 plus 1 is 4. That's going to be a positive number. 3 squared is 9. 3 times 3 is 9. 9 minus 1 is 8. And one last one, when n is 4, I would get negative 16/11. I'm going to skip putting 10 in because that would be quite big, wouldn't it? Well, I guess it wouldn't be that bad. Just looking for the eraser. Okay, we'll go ahead and do it. Putting 10 in. So it's going to be a negative. 100 on top. 3 times 10 is 30. 30 minus 1 is 29. So how about negative 129ths. The rule of the sequence is it's always 6, so this would look like a sub n equals 6 if I wrote it explicitly. And each of these terms is going to be 6, 6, 6. And the a sub 10th term is going to be 6 as well. Defining a sequence recursively. Recursive sequences are defined when each term following the first term of the sequence is defined with a previous term of the sequence. So this one says find the first 4 terms and the nth term of the sequence. And here's my rule of sequence. It says 2 times a times n minus 1. Well, if I think about if this is n, then this is the n sub n minus 1 term. So it's the previous term. And so here's a sub n, and then using the a sub n minus 1 term, I multiply by 2. So what you have to have in a recursive formula is you have to have a defined value. So right here, the a sub first term was equal to 5. Now they don't necessarily have to give us the first term, but boy, it sure is nice when they do. Then I'm going to use the rule of the sequence. It's for all n's greater than or equal to 1. So if I use 2, I'm on n equals 2, I'd have 2 minus 1, which give me the a sub first term. And I'm going to take 2 times that. So my a sub 2 is going to be 2 times the previous term, which was 10, or 5, giving me 10. The a sub third term is going to be like a sub 3 minus 1, which would be 2 times the a sub second, or the previous answer, which was 10. So my a sub third is going to be 2 times 10, and you can start picking the pattern up. My a sub fourth is going to be 2 times 20. My a sub n term would be 2 times the previous term, a sub n minus 1. And that should be pretty self-explanatory. All right. On the back, sequences in which pairs of successive terms have a common difference, let's start with that one, is known as an arithmetic sequence. And what you can see here is we started out with a, then we got a plus d, then I add d again, so now I'm really adding 2 d's to the first term of the sequence, 3 d's, and so on. So I end up with n minus 1 times d added with the initial term a. Each term can be obtained recursively from its preceding term by just simply adding d. So here's a recursive formula. We notice it's recursive because it uses the previous term in its calculation. Arithmetics, I like to think of them as a sub n equals the a sub first term if I have it, which not always, right? Plus n minus 1 times d, the common difference. So how many intervals have we added d to get over to our a sub nth term? Now, sometimes it's nice to know how to jump in at any point. Say they gave me the 5th term. I could use that 5th term by going, I want to find the n. I subtract out m. That'll give me the number of intervals of common differences and multiply it by d, and I'll get there. Okay. The other type of sequence that we commonly work with are the ones that we multiply by a certain number to get to the next, and that's a common ratio. These are called geometric sequences. Geometric sequences in which pairs of successive terms have a common ratio. The easiest way to find that common ratio is to take the term from the right and divide it by the term on the left, and that should get us the r. Each term can be obtained recursively from its preceding term just by multiplying by that common r. So here you see using the a sub n minus 1 term, multiply by the multiplying value of the ratio. That'll get us to a sub n. what did I want to write here? A sub n can equal our a sub first term times the common ratio n minus 1 times. And that'll take us and multiply however many times we needed to get to that nth term. If it was 5, then I need to multiply by 4 r's to get over there. To get r, we can take an a sub n plus 1 divided by an a sub n, right? Take the term to the right, divide it by the term on the left, and that should get you your common r. I suppose you could jump in at any point and say your a sub nth term is some a sub m times r, and how many times do I need to multiply by r? Not m first, I want n first. The n minus m. Tell me how many times I need to multiply. Given the arithmetic equal -3, 1, 5, 9, find the common difference. Well, I should be able to take the a sub n term minus the a sub m, or n minus 1, the previous one, and get it. So I'm going to take 5 minus 1, that'd give me 4. I could take 9 minus 5, it gets me 4. They should always be 4, shouldn't they? 1 minus -3, 4. Okay, I'm liking the common difference is 4. Find the 9th term. Well, I do have the a sub first term to work with, so I'll go ahead and work with that. I want to find a sub 9. I know a sub 1, and then I'd have 9 minus 1 times my common difference, which is 4. So my a sub 9th is going to be a sub 1, which is -3, added with 8 times 4, which is 32. 32 minus 3, 32 minus 3, 20, 29. Write a recursive rule for the a sub nth term. So I could find the a sub n term by looking at the previous term, a sub n minus 1, and then just simply adding the common difference. So for us, in this case, it's going to be a sub n equals a sub n minus 1 plus 4. And I need to give a starter value where a sub 1 was -3. And then my n, my rule would work for anything greater than or equal to 2, so that I could jump in and find my second term. Okay, so these are important that you note what was your starter value when you're doing recursive, and then let's define the n of where it's starting at or valid for. Then it says write an explicit rule. So my a sub n could be equal to, I'm going to start with -3, my a sub first term, added with n minus 1 common differences of 4. So what I was doing there, a sub n equals my a sub first, plus the number of intervals to get me over to that n. So an n minus 1 gets me the intervals, plus 4. That's not what I wanted to put there, though. I wanted to write d, the common difference. That should be all we need. If you wanted to, I guess you could simplify this down. I'd have 4n minus 4 minus 3 makes -7. There would be another possibility for this common difference rule. Let's move to geometric. For the geometric sequence, 1, -3, 9, -27, find the common ratio. So I'm going to do an a sub m. I'll do a sub n over a sub n minus 1. Term to the right over term on the left. So maybe I'm going to do a sub 3 over a sub 2. A sub 3 term is 9 divided by -3. Gets me -3 for my r. I could have used a sub 4 over a sub 3. Negative 27 divided by 9 gets me common ratio of negative 3. Should stay steady, shouldn't it? The 10th term. So we do have the a sub 1, but I'm going to pretend that we don't. Let's just jump in. I could also say a sub n equals a sub m times r to the n minus m. Because I want to show you, I know some of the homework probably will not always give you that very first term. Let's say we know the a sub third term, and we want to get to the 10th term. So I would have a sub 10 equals the a sub third term. My common ratio is negative 3, and then I'd have 10 minus 3 multipliers to get out there to the 10th term. So a sub 10, I'm starting at 9, and I need to multiply by negative 3 quite a few times, right? So if I'm at the third term here, 4, 5, 6, 7, 8, 9, 10, and I want to get to my a sub 10th term, and we're starting at 9, I would multiply by negative 3, multiply, 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 multiply. How many times did I multiply? 1, 2, 3, 4, 5, 6, 7. Or 10 minus 3. And then I should be able to get that number. Do I have that number? Nope, I've never stopped and actually gotten it. So take negative 3 raised to the 7th, add, and then multiply by 9. Write the recursive rule. I think recursive rules are kind of the easy one to write. I want to find the a sub nth term. That means I'm going to use the previous term and multiply it by r. So in our case, the a sub 10th term, I'm going to use the very first term, which was a 1. Okay, so it's a 1. Oops, write it, please. 1 times 3. Oh, I'm sorry, negative 3, isn't it? Our r was negative 3. So that tells me then I need a sub n minus 1 still there. Yeah. And then I need to define, then I need to define my a sub first term was 1. My r, well, I don't really have to define the r because you can read it in the formula. But I do want to say that n is starting, come on, n was greater than or equal to 2. So that I'm starting out with the a sub second term then. Let me do that. There we go. So this would be the specific criteria that I need. To write an explicit rule for the a sub 10th term, I would go a sub nth term is whatever I'm starting with. So I could start with this 1 times negative 3 to the n minus 1 power. And that would give me the number of jumps, right? Because there's one less interval than there are number of terms. Blank space, we don't need that blank space. The second and the fifth term of the geometric sequence are negative 6 and 48 respectively. Find the first term, common ratio, and explicit rule for the nth term. So we know we have the fifth term. We know we had the second term. So what I want to do is think about, this would have been n minus 1 for that power. So I have already calculated out 5 minus 1 would have given me 4 times that I would have multiplied by that common ratio. For the second term, it would have been a 2 minus 1 times for that common ratio from my beginning term. Now, what I do is let's simplify that stuff on the left. So a sub 1 over a sub 1 will reduce to 1. R to the 4th minus what's down there. Oh, just a 1. Minus 1 equals negative 8. So this is an r to the third equals negative 8. R equals cube root of negative 8. R is negative 2. Oh, common ratio of negative 2. If I think about, here's my a sub second term, a sub third, a sub fourth, a sub fifth. You can see how we'd have to multiply by an r, multiply by an r, multiply by an r, and we have an r cubed then. So what else do we need to do? Find the first term. So that first term, you could, so if the second term was 6, I could divide by 3, the common ratio, and get back to 2. So I would just go 6 divided by 3, and that will get me my very first term. We know the common ratio is negative 2. Ooh, this might be negative, right? Because I would have divided by negative 2. Or did I really mess that up, guys? I think I did. The a sub, let me do this again. Grr. The a sub second term is negative 6. Oh, no, I was fine. And I want to find the a sub first term, so I need to take this and I need to divide by negative 2, our common ratio. So that would give me 3. 3 is my a sub first term. Write an explicit rule. So I'm going to start with my a sub first, multiply by the common ratio, and then whatever term I'm trying to find would be n, and I got to multiply the r to an n minus 1. That should do. So we are not doing MyMathLab this year. I've got to either create a new one for you off of WebAssign, or maybe I can find something in Delta Math. So that'll be watch Schoology for instructions.